Completed what is roughly the first half of chapter 4. So I plan to do 2 videos for this chapter. I'll show the book first, as always. Oh, and I forgot to show the back in my haste. So also, there were a total of 14 proofs. I read the first 2 sections, but I also read the 3rd section to make sure that the second video does not take me too long to generate. This is going out on February 5th. There were 43 problems, 14 proofs. I'm up to 401 problems, 244 proofs. In my haste, I went too fast there. So chapter 4 is fairly predictable, yet interesting. The part of linear algebra that Axler likes the least, and that is determinants. So various rules for determinants, a geometric aspect of the determinant being the area of a parallelogram, plus or minus depending on the right-handed or left-handed, depending on how the vectors are lined up. More about the geometry. Very interesting material in my opinion. Then determinants of order n. The whole business of doing the cofactor expansions for determinants. Very interesting theorems for determinants. This proof, I'm making a note here. I have to come back to this lemma. I really had a hard time following all the different steps of this proof. I'll have to come back to it. Even though I never had to come back to it for the problems, this is a rare instance in the book where the body of a theorem sort of behooves me. Yet I wasn't asked to do anything about it. So these problems just numerical, which is always fun. And then I read 4.3. Some properties of the determinant, the Kramer's rule, and a proof for it in the book. N-dimensional volume from the determinant, and then that's it. Okay, so I'll show, this is a new notebook number 6. Started in January 3. Reading section 4.1. Then on problems, a few arithmetic errors. Got the true and false all right. And there were a few proofs. Nothing special to see here, in my opinion. There was an answer given, and I think I got it right. I mean, it's the same logic that is done in the answer. I gave myself 3/4 because I think this was done better. Then the next section, section 4.2. It goes through and proves theorems for type 2, type 1, and type 3. And type 1 is, let me go to it. Type 1 is when you interchange 2 rows. Type 2 is when you multiply by a non-zero scalar. And type 3 is when you add a multiple of a row to another row. And so in this section, that some proofs have to be broken by type. And some proofs are only for a specific type. And so the first one I think that comes up with is theorem 4.3, which eventually leads to, I think it's the determinant was type 2. Yeah, no, it's not type 2. I'm sorry. I did it. I don't think so. I think this is not type 2. I shouldn't have written that. That's misleading. Then this is the theorem that I had a problem reading. I tried to figure out the logic, but in the end, I just ended up writing it out. This is the way it is said in the book, and that's that. So the reading of section 4.2 was a little more involved. got all the true and false correct for section 4.2. And then realized after having done these problems that I had it wrong, that actually the factor, this factor, when you take out the 3 is really, you take out the 3 for each row, and that's why you get 27, not 3. Yeah, I did it wrong the first time. And that's 8, not 2. So I did this wrong. Even though there is no answer in the back, I figured out later that I had done it wrong. Made an arithmetic error here, otherwise fine. Made an arithmetic error here, but was pretty happy to see that I got this one correct. And I got that one correct. Yeah, I got these all correct. Yeah, then a few small proofs in section 4.2. And I got this right. The relationship between the determinants for the different types, and it's actually, the answer is given in section 4.3, the text, but I didn't know that, so I actually had to figure it out, and I did figure it out correctly. Where the determinants are the same for the matrix that is a type 3 change, or it's negative if you flip 2 rows for the determinant, and if you multiply by a factor, that factor is multiplying the determinant per row. Yeah, then just reading of section 4.3. Yeah, that's it.